Welcome to Math 105. We are covering chapter 2.2 today, which is compound interest. Compound interest, how does it work? So unlike simple interest, this interest you can earn on a savings, beginning to earn on itself over a set of compounding periods. So this compounding period could be over a continuous rate. It could be annually, monthly, weekly, daily, hourly, semi-annually. So it can go on and on. And the more you compound, the more that value is like being reinvested. And so as the interest grows, it begins to accumulate and build rapidly. Now, this has an equation. Oops. So if we're talking about compounding, we have your future value is equal to your PV times 1 plus R over M times MT. So we already know that this was your future value, something that matures, it's worth something in the future, your maturation, things like that. Anything that suggests you're going to accumulate something. Your present value, PV, is here. Present value is your called your principal, your original, your initial amount, something that suggests you have it right here, right now. Your rate is still R. Your T is still time. And now we have something new, which is this. Actually, I'll probably do it in red. This M right here. Now, M is called your compounding period. This is the values that might change. So monthly, weekly, daily, quarterly, things like that will suggest this M. Now, in your textbook, they also define this as a different equation. You'll also see this equation on any sort of formula sheets for the in-person class. If you see those formula sheets, unless I've made edits in the future. So this I, they have defined in your textbook, or maybe even the formula sheet. I is equal to R over M, and I'm sorry, that should be really an N. And this N here is really your M times your T. So in case you see that, this is your, what is it called? I can't even think about it now. You know, I'm gonna have to pause and figure that out. These both have a specific names, and I'm having a brain fart. Now, one other thing I do want to list, anytime you're asked for finding your interest rate or your interest earned for the compounding, we're gonna be using your future value minus your present value. This is the formula that we're going to be using a lot more frequently, as opposed to what we were doing in the simple interest, where we can just use present value, rate, and time. So with that being said, pause the video, see if you can try out example 1. It says, what is the future value of a $4,000 investment earning 2% interest per month for 8 months? Now, this monthly amount that is matching, that's good. We want to see that. If not, we're going to then have to convert one into another at times. So your future value of your present value, which is $4,000. Your rate, they said, was 2%, which we're going to move that decimal place over. This is already talking about months. 0.02. Your time is over 8 months. Again, key here is that these two match. No conversion necessary. So instead, we can just use your formula from above, R over M, M times D. Now, there is one thing that we haven't listed yet. We got your PV. We have your rate. And we have your time. However, we do not have your M. So let's go back into the problem and figure out where that is. So we said we have $4,000, 2% interest for 8 months, and oh, I noticed my mistake. They didn't tell us, and this is my edit that I made actually on my notes. It says to change this. So sorry. This problem should say compounding each month. Not month. Okay. So this is 12. So we can put that there. So sorry, I keep forgetting to change that to be more specific. So if it's saying compounding each month or compounding monthly, right? We always want to put it into the context of a year. So month being 12 months out of the year. So when we put this into your equation, you can write it as such on your paper, but you're going to be seeing on your calculators, you might want to do something like this, where you have 1 plus, and then any sort of division you might want to consider putting in its own parentheses, and then perhaps putting this in parentheses as well. So I'll show you this one on perhaps Desmos first. We have 4,000, 1 plus, and Desmos it's actually pretty smart. I'll show you. Hopefully it does it here, 0.02. When you hit divided by, it already has what our original function was going to look like. Raised to, let's see my little caret button, where did it go? I don't use this one as much. Oh, I see it. So in order to get an exponent, where it says a to the b, that's where you can put in your exponent button. So we have 12 times, 12 times. Not a huge fan of Desmos. No, it keeps doing that. We're going to have to put parentheses around here. 12 times 8. And notice that the reason why I had to change it is that the whole thing was being multiplied by 8, but we need the 8 to be in the exponent. And you'll notice that your answer is coming out to that right-hand side. We're going to be rounding to 2 decimal places. So it says 0.41, and then the 8 next to it will round us up to a 2. The next one I will show you in the other one. Okay. So your future value, if we're compounding monthly over your interest for that duration, we should come out to have $4,693.42. All right, let's try it again with example 2. To find the future value of 5 years on a $10,000 investment earning 6% per year with interest reinvested every month. Reinvested every month is a very fancy way to say compounded monthly. So if they don't say the word specifically compounded, instead if they use something that says reinvested, that's just another way to say compounding. So in our case, we have $10,000 right here, right now. They're telling us your time is 5 years. They have your rate as, what was it, 6%? And they said this is years, which matches. That's good. We want to see that. 0.06. And I just want to make sure, yep, And if it's compounding monthly, how many months are in a year? 12. So we're just going to pop that right into your equations. R over M, MT, $10,000, 1 plus, and we have 0.06 over 12. And I'm going to kind of write it as if I was going to be punching it into our next calculator, which is 5 times 12. And if you wanted to simplify, you can always multiply out. If it's a quick multiplication, like this one's going to be coming out to 60, that's okay. It won't mess up your answer. Now I'm going to be using not Desmo's, my graphing calculator in this one. So you have $10,000, 1 plus, and I'm going to be having, especially in this calculator, we definitely want to work on getting your fractions into its own parentheses. Now I'll show you here because it's going to be coming up in our next section. Unlike Desmo's, where when you hit the division button, it creates a fraction. In our calculators here, if you have it, it won't automatically do that. Some of them will, some of them won't. Now, for some of your calculators, if you go over to this math button, and then it might be that first one, actually, it's over on this part where it says frac. Notice that I went from math and I'm going over where it says NUM number, CMPLX complex, and so forth. It's going to be that first one, your first option there. If you don't have it, it could be that your calculator is a little older. If you are using the app, you'll find it where I have it here. So I'm going to hit that just to show you that it will pop up with a fraction, so you can enter that in really quickly. If you don't have it, that's okay. You're just going to proceed by typing in your rate, the division, and then your compounding period. Make sure you close your parentheses because it will come up with some sort of error if you open one and don't close it. Do the little caret button, which right under clear is the little exponent button. And then 12 times, what was it, 6? No, 5. Go ahead and hit enter. And there you see we have our answer. And again, rounding to 2 decimal places, 501. That one is going to leave our 0 alone. And there you go. Right, I would suggest if you haven't paused on the last two, pause it here, work it out, see if you can try it in your calculator. It says in December 2015, Radius Bank was paying 1.10% annual interest on a savings account with a balance of $2,500 deposited 6 years and compounded quarterly. What is the total interest paid over the lifetime of its investment? Okay, so this one wants to know the total interest paid. So we want to end up with your INT. But keep in mind, your interest is really your future value minus your present value. This is what we need. Now, before that, while we have your present value, we don't have your future value. This is what we need to figure out beforehand. And no, we are not able to use your simple interest formula right there right away. So let's figure out what is given. Present value, we said, was 2,500. Your rate is 110%, and this is yearly or per year. Moving that decimal place over, we're at 0.011 or 110. Your time, we said, is 6 years. So these match. We like that. It looks good. And M, how many compounding do we have? Quarterly. So how many quarters are in a year? There's 4 quarters in a year. Now, my students who are studying for their final or who have taken their final, I was seeing a lot of 0.2 2 5s. I'm not sure where that came from. We're not dividing by 12 here. I guess that's how they got it. I'm not quite sure. But we're looking for a nice whole number. So let's go ahead and find your future value, which is PV 1 plus R over M times MT, 2,500, 1 plus, let's see, your rate, 0.0114 to the 4 times 6. Now I'm going to do this again in the graphing calculator because that one is a little harder to input at times. So we have 2,500, 1 plus 0.011 divided by 4. Now notice I did not do my fraction button. If I wanted to, I can. But I'm just showing you that it'll come out no matter what. Close that little parentheses doing the division, and then close out the bigger of the 2 parentheses, raise to the 4 times 6, I believe we have. And there we get $2,670.32. Okay, now while this is your future, we're not interested in your future. We need your interest, which we need to calculate as your future value minus your present value. Again, we can only do this formula for your compounding, or if you're compounding. So we have our answer minus what we started with. We can just pop that into your calculator fairly quickly. So I'm not too worried about that. I want to emphasize, do not use INT equals PVRT only for simple. I want you to all write that down. It's not an option for me. I need you to put that somewhere on your paper because when you look back, I need you to be able to pinpoint why we're using this formula, because it happens every semester. Students, when using their notes for their homework, their quizzes, or their tests, they keep getting the same questions wrong and they don't know why, no matter how many times we reference this particular problem. Okay. Now there's a concept called the time value of money. Which is a concept that a given amount of money received now will usually be worth a different amount to us than the same amount received at some point in the future. So pretty much we are going to be different people, different circumstances happening, or different circumstances are happening. So if you give me some 10 grand now that might mean a lot more to me right now than maybe in the future when I'm a little bit more well off. Now, under some circumstances too, think about inflation, things like that, that go into certain factors that will also change the concept of that money. So now your present value. Your present value, just like we had with your future value, I'll show how to get there. Right now, we only have this equation to go off of, which we need your present value, right? So again, just like last time, As long as this whole thing here is being multiplied and it's all in parentheses, we can then divide it out. So placing it to the other side of your equal sign, and we can cancel out on one side, and we're left with the following formula. PV is equal to future value divided by 1 plus R over M times MT. Now this is where that fractional button might come in handy for those who are using a TI 83 or 84 or some such model. Use fraction button on TI 84 or like models. So to get there, you can do the math button over to where it says frac, and then it says something like n/d. Or you can hit alpha, the green button, y equals, and then again, one that's labeled n/d. So they're located in a couple spots. I'm sure there's more places to find it, but this is these are the two that I'm aware of. Okay. So let's move on. It says example 4, Megabuck Corporation is issuing a 10-year corporate bond paying no interest during its lifetime, but promises to pay their maturity value at the end of 10 years. How much would you pay for the bond with a maturity value of $10,000 if you wish to get a return of 6.5% compounded annually? Now, when it says maturity value, they mean future value or par value, right? So your future value is given, and now we need to figure out, well, what did you pay for it, right? So in our problem, they said future value is $10,000. Your rate is 6.5% per year. Your time, we said over its lifetime, is a 10-year bond. That's really nice because these are matching values. And your M, what type of compounding do we have? Compounded annually. So how many years are annually? Well, that would just be one. Annual means 1 year. So we're going to throw that into the equation. PV is equal to FV over 1 plus R over M times MT. So we have $10,000, 1 plus, and I'm going to put in all the parentheses where they actually, in this case, because it's over 1, I'll show you why. If we did do it like this, 6.5 over 1 to the, what was it, 1 times 10, like that. Notice that because it's over 1, it won't make much of a difference. So you can actually get rid of that bit. I might just rewrite this one a little bit better. And if you wanted, 1 times 10 is still 10. So we can go ahead and plug that in. And I'll do the graphing calculator one more time because that one is a little harder to work on. However, this calculator is the most useful to us because Desmos I'm going to be starting to inch away from come chapter 8 for sure. So you said 10,000. Oh, actually, let me show you that fancy schmancy fractional button again. So hit math, which is located to the right hand or left hand side right below the green button. Go over to frac, which stands for fraction, and click on it, and then you have your fractional button. So we're having 10,000 above, still using parentheses, 1 plus 0.065, or you can add them together, raised to the 10. Go ahead and hit enter, and we should come out with this response. Okay, I want to make sure that we answered the question. All right, there you go. Now, a couple more things to note. You can have a zero coupon bond. Let's see, sorry. A zero coupon bond is a form of corporate bond that pays no interest during its lifetime, but promises to pay the maturity value. And we're also going to be talking about your inflation. Inflation, if you hear the word inflation, is actually going to be more like a compounding problem, which is just your reinvested interest. So if we have the following question, we can say that inflation in North Avalon is 6% per year, which is more expensive? A car costing $2,000 today or one costing $22,000 in 3 years. So initially, yes, 22,000 sounds a lot more right now. But again, we're working with inflation and we know that that actually could be not the case. So we have two things going on. 6%. So right now, your present value is $20,000. So we're working with the today portion. So right now, today. Okay, if we went to buy a car, it's going to cost $20,000. However, we can have some time later in the future. Three years later, right? 3 years later. So your present value, we don't know. We want to compare the two cars. Should I get the $20,000 car right now or one that looks like it's going to be a lot more expensive, $22,000 in 3 years, right? So we don't know your present value. We know your 6% interest. We know your 3 years. And your compounding, well, they don't say it, we're going to right now just assume under the same context, it's just going to be 1 year annually. So if we have, oh, and I need my future value, $22,000, because we are in the future. So $22,000 in the future. So present value is 22,000 over 1 plus, and just to convert this, right, just move your decimal place over, 0.06 over 1. Again, because it's 1, you can just erase that if you'd like to the 1 times 3. So when we go to put this into your calculator, and I'll show you the Desmos side right now. So we have 22,000 divided by 1 plus 0.06, yep, raised to the third. Okay, so when we get it out, we have 18,471.6. 18,471.62. Okay. So what our answer on this half means is that, okay, well, this is in the future, 3 years later. We're still buying the same exact car, same model, same everything, right? We're just working 3 years in the future, okay? So if this is what we have in the future, right, our present value, right, the value that it actually is worth, this car, we could get it for actually $18,000 versus right here today, it's actually going to be a $2,000 or $20,000 car. So which price would actually be better, right? This car value, if we wait 3 years, while it looks more expensive in today's money, it's going to be a lot cheaper, right? That's how sometimes inflation is going to work. So this one is more expensive. That looks horrible, that handwriting. This one is the better car option. Okay. So let's try the next one. So it says you have just won $1 million in the lottery and are deciding what to do with it during the next year before you move to the South Pacific. Bank 10 offers 10% interest compounded annually, while Bank 9 offers 9.8% compounded monthly. In which should you deposit your money? Again, 2 things happening at once. I would pause the video and see, pause the video and see if you can do it yourself. All right, so we are going with Bank 10. So this is Bank 10. Your present value, we just won the lottery, so it's $1 million. Now we can keep everything already in millions, or you can write the whole million value. So I am going to choose to keep this dollar signifying as a million amount, which means when I go to evaluate my answer, it should also be in millions. Now your rate, we have 10% interest or 0.1. Your time, we said, is over 1 year. And we're compounding annually for this case. All right, so Bank 10, we have your future value is equal to 1 year million, so 1 million plus 0.10 divided by 1 if you'd like, raised to 1 times 1 again if you'd like. So we really have 1.1, and this is millions. So $1.1 million. That is if we go with Bank 10, offering a 10% annual interest rate compounded annually over that year period. Okay, let's do it again. So that's Bank 10. This time we're working with Bank 9. So same type of context. Your present value is still in millions. Your rate is a little different. We're working with 9.8% or 0.098. Your T is still over that next year. However, this time we're compounding monthly. So a slight change. Oops, present value 1 times 1 plus 0.098 over 12 to the 12 times 1. We're gonna get out. If you plug that into your calculator, hopefully you got out something like this. If you just wrote out millions, that's okay. You're gonna have the same, mine is just in scientific notation, so it's a little bit shorter and smaller. So comparing the two,